Welcome to The Invisible Backbone, a documentary about the buildings that power the modern world. United States data centers. Every time you scroll social media, search the web, stream a movie, or ask an AI a question, you're reaching out, invisibly, to one of the most powerful and least understood structures in modern America. These buildings don't make anything you can hold. They have no windows. They rarely appear in magazines or on travel guides. And yet, without them, modern life as we know it would simply stop. They are called data centers. And in the United States, they have become the hidden infrastructure of civilization itself. This is their story. To understand data centers, we have to go back to the dawn of the computer age. To rooms that smelled of hot metal and cigarette smoke, where the machines were as big as houses and just as fragile. The first true milestone came in 1946, with ENIAC built at the University of Pennsylvania. ENIAC filled an entire room. It weighed 30 tons. And it consumed 150 kilowatts of electricity. Today, the phone in your pocket is millions of times more powerful. But ENIAC showed the world something extraordinary, that machines could solve problems faster than any human. Governments and corporations took notice. Through the 1950s and into the 1960s, large organizations, the military, federal agencies, banks, universities, began building dedicated rooms to house their computer equipment. These weren't called data centers yet. They were called machine rooms or computer rooms. IBM, the dominant technology company of that era, emerged as the key architect of this new world. In 1963, IBM's Federal Systems Division established one of the first purpose-built computing facilities in Owego, New York, specifically designed to support the U.S. Department of Defense. The age of the data center had quietly begun. By the 1970s, the term data center had entered the business vocabulary. IBM was building bigger and more powerful mainframe computers, the System 370 series being among the most influential. Banks used mainframes to process millions of transactions. Insurance companies ran actuarial models. Airlines automated their reservation systems. And the U.S. government ran payroll, tax records, and national defense through these hulking machines. A mainframe failure didn't just slow things down, it stopped everything. So data centers were engineered with redundancy, backup power generators, multiple cooling systems, and strict physical security. This era also saw the rise of time-sharing, the conceptual ancestor of today's cloud computing. The 1980s brought the personal computer, putting computing power on desktops across America. Apple, IBM, and a wave of startups transformed the industry. Corporations began building internal networks, connecting their PCs to shared servers. But at the organizational level, data centers kept growing. The U.S. military, meanwhile, was building something that would change everything. It was called ARPANET, the precursor to the Internet. If the 1970s built the foundation and the 1980s built the walls, the 1990s blew the roof off entirely. The commercialization of the Internet triggered a demand for data infrastructure unlike anything before. Suddenly, every business needed a website. Every startup needed servers. The dot-com boom had arrived. From 1995 to 2000, hundreds of new data center facilities were built across the United States at breakneck speed. The model of colocation emerged, where many companies would rent space in a shared building, splitting the cost of power and connectivity. One place in particular became the epicenter of this revolution: Ashburn, Virginia, a small town in northern Virginia near Washington, D.C. Thanks to its geography, its proximity to the major East Coast fiber backbone, and favorable local regulations, Ashburn became the single most connected place in America. Today, it is known simply as Data Center Alley. More internet traffic passes through Ashburn than through any other location on Earth. When the dot-com bubble burst in 2000 and 2001, many companies collapsed. But the infrastructure they had built, the fiber, the facilities, the power connections, did not disappear. It sat waiting. Let's take a moment to look at the full arc of history. From the mainframe era of the 1940s and 1950s, through the PC revolution of the 1980s, the internet explosion of the 1990s, and into the cloud and AI eras of today. Each wave built on the infrastructure left by the last, and the pace of change has only accelerated. In 2006, Amazon made a quiet announcement that would reshape the global economy. The company launched Amazon Web Services, offering businesses the ability to rent computing power and storage over the internet, paying only for what they used. It sounds simple. But it was revolutionary. For the first time, a startup could launch with no servers of its own. Computing had become a utility like water or electricity. Microsoft and Google quickly followed with Azure and Google Cloud. By the end of the 2010s, these three names controlled more than half of all global cloud computing. Today, the United States is the undisputed capital of the global data center industry. There are more than 5,000 data center facilities operating across the country. The U.S. market was valued at roughly $135 billion in 2025. The United States is home to more than 54% of all hyperscale data center capacity on the planet. The U.S. data center market is projected to nearly triple, reaching nearly $400 billion by 2035. Growing at over 11% annually, it is one of the fastest growing industries in the American economy. The primary driver is artificial intelligence, cloud computing, and the explosion of digital services that touch every aspect of modern life. This map shows every data center in the United States operating, under construction, approved, and proposed. The teal dots are facilities already running today. The orange dots are under construction or approved. The blue dots are proposed facilities that companies want to build in the coming years. And the larger the dot, the greater the power capacity. What immediately stands out is the sheer density of activity in a handful of regions. Northern Virginia dominates the East Coast, Texas and Dallas anchor the South, and California's Bay Area and Los Angeles form a dense cluster on the West Coast. But look beyond those familiar hubs, and you'll see orange and blue dots spreading into Ohio, Indiana, Georgia, and across the American interior. This isn't just where data centers are today. It's a map of where America's digital infrastructure is being built right now, and it is vast. And driving all of this? Artificial intelligence. Every AI chatbot, every image generator, every recommendation algorithm runs on hardware housed inside data centers. Training a single large AI model can consume as much energy as powering dozens of homes for an entire year. As AI capabilities have exploded, so too has the demand for the physical infrastructure to support them. American companies dominate the industry. The Big Five hyperscalers Amazon, Microsoft, Google, Meta, and Oracle have collectively committed between $660 and $690 billion in capital investment for 2026 alone. Roughly 75% of that, around $450 billion, is targeted specifically at AI infrastructure. The scale of this investment is almost incomprehensible. But this extraordinary growth comes with extraordinary costs, and not just financial ones. In 2023, American data centers consumed 176 terawatt-hours of electricity, enough to power 16 million homes for an entire year. The strain on the power grid is real and growing. PJM Interconnection, the grid operator serving more than 65 million people across 13 states, has warned it may fall short of reliability requirements as soon as 2027. Modern data centers also use tens of billions of gallons of water annually to cool their servers, often in water-stressed regions already facing drought. By 2028, data center electricity consumption could double or even triple, potentially reaching 12% of all electricity consumed in the United States. The problem is speed. Data centers can be built in 2 to 3 years. New power plants and transmission lines take much longer. Transformer lead times have stretched to over 3 years. Studies suggest the data center boom could drive average electricity bills up by 8% by 2030, and by as much as 25% in Northern Virginia. The industry is not standing still. Microsoft has pledged to be carbon negative by 2030. Google has invested heavily in matching its consumption with clean energy. Amazon has become the world's largest corporate buyer of renewable energy. New liquid cooling systems run coolant directly over computer chips, dramatically reducing water use. Several major tech companies have signed agreements with nuclear energy suppliers, viewing small modular reactors as the only energy source that can deliver the consistent, round-the-clock power that AI data centers require. The next frontier is also smaller, modular microdata centers deployed closer to the people who use them. From a room-sized machine in a Pennsylvania university in 1946 to vast campuses humming with the energy of small cities, the American data center has traveled an extraordinary distance. It has been the engine of the internet economy, the backbone of the cloud revolution, and now the foundation of the artificial intelligence era. It has transformed how we work, communicate, learn, and even think. The data centers that hold our world together are invisible to most of us. They sit in the quiet corners of cities and the wide-open plains of the American interior, doing their work in silence. But make no mistake, they are among the most consequential buildings ever constructed. And their story is still being written.